Okay, so hello future engineers, welcome once again to Differential Equations. So for this discussion video, we will have just a glimpse, an introduction to the real subset differential equations. So for this, we have definition, classification, order, degree, and linearity of differential equations. All throughout this video, you are expected to define and identify definite concepts and theories in differential equations. So this will be a series of videos. So I do hope that this will be clear for all of you later on. So classify linear or nonlinear and homogeneous or non-homogeneous ODE. So the dependent and independent variables of a differential equation. So the first question is, what are differential equations? So calculus, the science of rate of change, was invented by Newton in the investigation of natural phenomena. So so if we go back to the history of calculus, so the goal is to investigate the natural phenomena. Many other types of systems can be modeled by writing down an equation for rate of change of phenomena. So, kinailangan natin studihan ang differential equations because in the modern world or in reality, coexist or ginagamit ang differential equations, especially in the field nga muni, but not limited to the following. So we have number one, bandwidth utilization in the TCP networks or mga networks, mga internets na ginagamit natin. So we have bandwidth utilization, kung paano ginagamit ang bandwidth for communication. Next, acceleration of car. So may differential equations there. Population increase. So tanan na may ara sang differential equation. Even the spread of certain virus spreads ang COVID, for example. So there is a differential equation behind that. So chemical change of some kind, so kung paano nagkakatabo ang mga reactions. So we have differential equations. Next, mga locus of a football, for example. So differential equations. So next, all of the above behavior can be captured by very simple differential equations. So let's start this discussion by defining what are differential equations. So it is a mathematical equation that relates a function with its derivative. That means that's why ginatawag siya natin differential equation. So the function usually represents physical quantities, derivatives represents its rate of change. So differential equation defines a relationship between the two. That means nga ang ating nga differential equation is an equation nga may ara kita sa certain parameter and then may ara dira sa derivative values. So differential equations. So for the history or the origin of differential equations, so we have to go back, bisan gamay lang ang concept dali. Sino ang naka-invent sa sininga idea? Ano ang background sa sininga? Kabilugan ng concept of differential equations. So we have here, origin of differential equations. So syempre, hindi naman na siya natin ma-avoid pa or hindi na siya natin malipatan pa. That mathematics history of differential equations, pwede siya natin i-go back liwat to the history of calculus. And the history of calculus so was traced back into the concepts invented independently by the mathematician. First, we have the English na physicist nga si Newton, kag German mathematician nga si Gottfried Leibniz. So duwa sila, pareho sila may ara contribution in the field of differential equations because of their advancements and their discoveries in the field of calculus. So let's Proceed, I mean, to differential equations. An equation that contains one or more derivatives of one or more unknown functions with respect to one or more dependent variables. So, both silingon may ara ka derivatives in either isa or damo ang type of derivatives nga present in a certain equation. Kag either may ara ka man one or damo nga variables. So, that is a differential equation. Examples in diri, I have here, so we have y, so third derivative, so naka-squared pa siya. So may literally y, that second derivative, we have y prime. So is a dependent variable y and the independent variable x. So umano siya, para diri. So since naka-derivative ang ating y, so dependent siya. Independent nato ng x. For this one, we have sa ari sa dalom, so we have dv over dt is equal to 1/3 pi r dh over dt plus 2h dr over dt. That is a differential equation with dependent variable. So atong dependent variable diri. So dependent nato nangaritan sa sa babaw. So take note ang aton nga kalabanan ang aton gid nga independent variable ang ara sa dalom sa aton nga derivative. So diri sa babaw we have y prime pero kung na-representa na siya by a fractional form dy over dx. So dx is your independent variable ang ara sa dalom. Diri naman sa dalom we have independent variable ang dt. Ara siya tanan sa atong denominator. So ang kanang ara sa numerator dv dh dr is a dependent variable. So this is a differential equation o sa babaw because, so take note, hambal natin kagina by the definition. Usually, this is a differential equation, kaya naka-prime. So differential equation, derivative component na siya, basta naka-prime. Next, differential equation man ni Japon, kaya may harap sa amuning representation. Pero basta naka-D ang muna niyang representation, naka-D operator. So it has differential component. Ari, take note, derivative component ang sa first equation, dali naman yung differential components. Next, ikatatlo natin yung equation. Hindi na ni siya differential equation because it does not have differential nor derivative na components in it. Wala tali siyang differential or derivative na component. Next, sa ikaapat naton diri nga equation, hindi na siya differential equation. This is not a differential equation because it is not a form of equation. Dapat ma-equals ka sa piyak para maka-create ka equation. So, even though kakita naton nga meron kita sang derivative component. Next, an equation that contains one or more derivative of one or more unknown functions with respect to one or more dependent variable is a differential equation. So, parehas ni. So, damo-damo na possible ng variables ng treat. We have this one. So, we have kung ano mga variables. Tara. So, kung ano sa denominator again, so tanan nga sa denominator, so we have independent na siya. So, we have P, we have T. So, we have P kag T as independent. Ang kanan sa numerator will be your dependent. Beta, K, so dependent variable. So, some of the known or kilala nga the differential equations are the following. So later on, you understand naman ni. So we will have specific nga topics for Newton's law of cooling. Gamiton na siya natin specifically for even for the studying of saan na ga-cold, saan anong time exactly mag-cold ang specific nga hot nga liquid, saan exactly napatay ang specific nga body or napatay or asan ang time of death that will be through Newton's law of cooling. So, pwede na ma-solve. Next, material balance and chemical mixture. So, tanan ni. So, for the chemistry applications, so may DE man that. Next, Torricelli nga law of fluid motion. So, which is ginagamit for civil engineering. So, this one. So, known na sila nga mga differential equations. So we have also Laplace equation. So for Laplace equation, this one, we have a specific topics related to this. So medyo halos siguro nga pre-final classes will be on the Laplace equations. Next, we have heat equation. So this one, so higher ng mga engineering subjects will focus on heat equations also. So next, we have to learn how to classify differential equations. So pwede natin i-classify ang differential equations sa damdamang possible ways. Number one, by type. So by order pagid, by degree, or by linearity. So tanan ni, so ang matamaton siya naton badbad, ang matamaton naton discuss. So by type of differential equations. So if only ordinary derivatives appear in the differential equation, and then it is said to be an ordinary differential equation. Take note, kung ordinary lang ang derivative, ano na siya? Parehas ang dy dx natin. So if the derivatives are partial derivatives, and then the equations are called partial differential equation. So we have here dx over dt. So very very simple ng derivatives. Ordinary lang siya, dx over dt. So tanan ni, we have the ordinary lang siya nga differential equations. So we have here, so differential equations, example ng sini. So in applications ng differential equation in the field of electrical engineering. So we will have more of the examples of ordinary and partial differential equations sa piyakang discussion video. So dito talagang i-plus target sa inyo. Next, by order. So the order of differential equation is the order of the highest derivative that appears in the equation. So take note o tanawon naton ang itsura sa atong differential equation. Tanawon mo lang di anong pinakataas nga derivative diri. So pinakataas dato nga derivative is ari second derivative. So what's meaning this one is a second ordinary differential equation. Next, para diri wala naman kita sa mga exponent diri sa atong differential component. That means first order differential equation na siya. Next one, degree of differential equation is the exponent to which the highest ordered derivative is raised. Okay, kung ano itong pinakataas naton nga derivative, kung ano nang iya exponent, amo na ang degree. It is the algebraic degree with respect to its derivative. So the definition of degree of DE used here is relative to the derivatives only. That is the rationalization and clearing of fractions with respect to the dependent variable need not to be performed. A DE may not have a degree if the DE cannot be expressed without any transcendental function of the derivative of any dependent variable, then that DE is said to be no degree. So sa aton nga mga next nga mga discussion video, may plaster naton about sa degree, order, and mga removing of or eliminating of arbitrary constants, makita na siya naton. Okay, so we have here by degree. Example, so ari, so tan-awon naton kung ang by degree tan-awon ta ang pinakataas nga derivative, so that means ari pinakataas naton nga derivative. So then ano dayon ang iyang exponent. So ari, ang sagwa, that is your degree, amo ni aton order ang sa sulod. So this is a fifth order third degree. So take note una, kada permiyang degree kung magsulat ta. Pwede lang man depende kung ano ang. So third degree, so ari siya sagwa, fifth order ODE. So third degree, fifth order ODE. Kung ano ang pinakataas dari nga derivative. So next, amo ni ang representation. So that means tatlo ka x, so it is third order. Kung ano yung exponent, that is your degree. So fourth degree, third order, so partial differential equation. Basta nakaamon yun yung pag-plus star, partial differential equation na siya. Next we have, so amo na yung representation. So this is already a, so original formal ang yung representation, hindi siya naka-partial form kaya wala sa dalong So that is your ordinary differential equation. So y prime lang siya, proceeding on first order siya. Wala man siya sa exponent, so automatic first degree. Okay, so di naghalin ang differential equations or paano siya ginaplastar. So it is for a equation. So even ang family of straight lines, pwede siya mag-represent sa differential equation. So if we look at the representation of a simple line, so dapat originally y is equal to mx plus b. So madula lang muna sa Japan because ito plus b dari will be your reference muna sa graphing. So but if we perform dari kung tanawon ta, your m is your slope, where your slope is also represented by dy over dx. So kung ibalik natin sa calculus, dy over dx equate siya sa m kay pares man sila slope. So that will be equal based sa ating equation m is equal to y all over x. So pwede gali nga kung isilhon ko tong x mo siya x dy over dx is equal to y. So this already is a differential equation. Ari ta di iban nga mga values and then meron kita sa differential or derivative nga component. Differential components. So example now we have the family of curve naman siya. So this one, curve naman siya. So kami cosine kita. So tanan ni basta nakaamo na yung form. So pwede tanong derive direction dy over dx. Nakuha ni nato na value. Differential equation na siya. So kung i-derive dapat what second order na siya nga differential equations. So mula na sa simple ang itong introduction for differential equation. If you want to study the concept of differential equation, pwede nyo i-search RDO. So, but I will be discussing or will be attending another discussion video for differential equations because I have a separate module for the introduction or RD man nga daan sa inyong mga books. Ang aton nga introduction to differential sa aton sa inyong mga module, I mean, ang aton introduction to differential equations. But for now, hasta lang tagdanay, the very small lang nga introduction for the topic on differential equations. So, I do hope you will find time to do a research na lang daan for differential equations and watch out lang for the next discussion video. Thank you. Stay safe. God bless.